Organic Chemistry, Chem 212, Exam 1 Material, Part 3. Now we're going to start naming these alkanes. Okay, we've kind of looked at some of the basic pieces on naming. So you need to name the main chain. That's going to be the parent chain. That's the longest continuous chain of carbons, regardless if it bends and twists. So you can see my technique for doing that is to actually circle it. I physically circle it. Anything that's not included in the main chain would be a substituent or something branching off of that. And then you would give whatever's branching off of it the lowest number, either reading from the left or to the right. And we'll get some examples of that. You need to identify what the branching group is. It could be a halogen, or it could be a methyl, ethyl, or some kind of alkyl group. And then you name it as a single word. So this isn't the only rules to naming alkanes. There's actually a few other things that go on. So during the next few slides, I'll try to introduce some of the variables that happen, and so you can get them all after the next few slides. So one of the first things, in addition, I want to give you then these rules, and we'll definitely practice those, is anytime you have two addresses of the same thing next to each other, numbers and numbers are always separated by commas. So I have an example of that here. So if you have a 2 and a 3, you'd have to put a comma between them. If you have a number and a letter, and again, when these come into play, I'll show you on the next slide or the next few slides, anytime you have a number and letter, that's separated with a dash. These commas and dashes are extremely important. So on an exam, if you're missing a comma or you're missing a dash, you will be marked off for it because it does mean something in its name. These rules here, or these ways to name A, B, C, D, on the next few examples, I actually still label them A, B, C, and D to help you match it to this. So take a look at the next slide. I have example 1, so you need to draw that in. That's not in your notes. You have to draw this example. And then I actually gave you the answer. And that's okay, because sometimes it's nice to work backwards. You have the answer and you can work with it. So draw the structure, and if you notice, letter A, which is find the longest continuous chain, regardless of bends and twists, it has 5. So let me show you how I do that. Let me get my pen going again. All right, so looking at the structure, my longest continuous chain, regardless if it bends and twists, is 1, 2, 3, 4, 5 carbons right here. So I'm going to go ahead and circle that. And now I know that that's going to be a pentane. Now, when you are asked to name a structure, so if the structure is already drawn for you, and you have to name it, you can write whatever you want on the question. So that's what I like to do, is I like to mock this up. I like writing all over it. So that would be a pentane, and I wrote my note over here, but I also showed the answer here. Next, we need to see if there's anything branching off of it. Do you see this piece right here? This is something not included in the parent chain. In fact, it only has 1 carbon, so I now know that's a methyl group. So I'm going to go ahead and write that as my notes over here. Well, what we have to do is we have to determine the numbering system. Is this coming off of carbon number 2 if we read from left to right, or is it coming off carbon number 4 going the opposite direction? Well, it's either 2 or 4. Do you guys see that? Well, the rule is you have to go in the direction that causes the lowest composite number. That means I have to read it from left to right. And if we take a look at these carbons, that's carbon number 1. This is carbon number 2. And if I really wanted to, actually this isn't going to do me any help me at all, but I can go ahead and number all the carbons in the chain. Do you notice that my methyl group is coming off carbon number 2? If I went in the other direction, it would be 4, and that's a higher number. You always have to use the lowest number. So now not only do I have a methyl, but I specifically have a 2-methyl. So that's going to be some of my notes here. If you notice, I've taken care of all the carbons in the parent chain with the name pentane. I've taken care of anything branching off of it. This is a methyl, and he lives on carbon number 2. So let's take a look at my notes here. How you're going to do this is, we know it's a pentane. I numbered my carbons, and you number it from the direction that gives you the lowest number for whatever's branching off of it. I know I have a 2-methyl substituent. I went ahead and wrote that here. And then you write it as a single word. Pentane is the parent. The parent name gives it, the parent gives it the last name. So notice the end of this is pentane. And then in front of that, there's no space here, I have 2-methyl. The reason why there's a dash between the 2 and the M is because anytime I have a number and a letter, I have to put a dash there. So that's why it's 2-methylpentane. All right, so what I also have in your notes here, you might want to draw this. I'm not sure if you have this in your notes or not. I wanted to show you that this is the same as this. When you have a halogen, the name of the halogen, if you have F, would be fluoro, Cl would be chloro, Br is bromo, and I is iodo. And anytime I have them as a substituent, I treat it just like I did the alkyl group. I need to number where it's at, and I'll include it in the name. So let's see what we have here. Example 2. So you need to go ahead and draw the structure in your notes. And again, I know I have the answer there, but let's take a look at it step by step. Longest continuous chain, regardless if it bends and twists. I went ahead and made it go straight again, but I want to warn you, in some of my other examples, they actually bend and twist. So we have 1, 2, 3, 4, 5, 6. So 6 carbon single bonded, what would that last name be? Hexane. Now I have 2 substituents here. I have a Cl and I have this group. Do you remember the name of this group here? It has 2 carbons. This is an ethyl, E-T-H-Y-L, ethyl. That looks like a C. There we go. Ethyl group. And this one up here, I told you that's a chloro. So where do they live? Well, if I go from left to right, they're both on carbon number 4. But if I go from right to left in this direction, did you notice they both live on carbon number 3? So anytime I number my carbons, I put them in circles because I don't want to mistake them for these subscripts. Do you see that? So here's carbon 1, here's carbon 2, here's carbon 3, here's carbon 4. So that's why I always put circles around them, because I don't want to mess up with that. So I actually have my chloro living on carbon number what? 3. So in front of that, because it's a number and a letter, it'd be 3-chloro. My ethyl also lives on the same spot. I still have to tell the reader in the name exactly where it lives, even though it might be the same as the other. So it lives on a 3. So this is a 3-ethyl group. So I have a hexane, and I have a 3-chloral and a 3-ethyl. How do you put all these together? Well, let's take a look. I have a hexane. You number the carbons. And I have a 3-ethyl and a 3-chloral substituent. Okay, that's where we're at. We already know that. So how do I handle it when you have 2 different substituents? When you have 2 or more different substituents, you list them or name them alphabetically. Now my 2-ethyl's in a very bad spot there, so I'm going to rewrite my 2-ethyl. I'm just going to go ahead and write it over here. It's a 2-ethyl. This is supposed to be a 3-ethyl. Why in the world did I write 2? There we go. Sorry about that, guys. All right. I have a 3-chloro and a 3-ethyl. You don't care about the numbers. The numbers are a physical thing. I need to list these alphabetically. Ignore the numbers right now. Look at the first letter. This is the letter C, and this is the letter E. What letter comes alphabetically first? Chloro does. So when I list this name, take a look at what happens. The 3-chloro comes first. Then I have to do a 3-ethyl. Do you see this other dash right here? Anytime you have a letter and a number, I don't care if it's to the left or to the right of the number, you have to use a dash. And so you can see why we use these. So I have 3-chloro, the C comes before E, 3-chloro-3-ethyl hexane, all written as one word. So on this page here, we have an example of, you can have the branching coming off the left or right, and you always look for the lowest possible number. On the second example, we have 2 different substituents, and we had to learn from this one that if you have 2 or more different substituents, they're listed or named alphabetically. All right, here's example 3. Now, I want you to go ahead and draw this, but I want you to go ahead on your own and circle the longest continuous chain without me. So the longest chain actually is bent. It's not straight across. It goes this way. So let me help you count. Kind of went high there, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8. Now if you went straight across, you would have only gotten 7. So the longest continuous chain, regardless if it bends or twists, and this one does bend, is 8. So the last name of this compound is going to be octane. So what you see in the answer is when you... So this is a formatting issue. It would have been easier for you to name it if I would have written these all in a straight line. Well, they don't always come in a straight line. Sometimes they bend, sometimes they twist. So it's your job to go through and find the longest chain regardless if it bends and twists. So there's 8 going this way, there's 7 going this way, and there's 1, 2, 3, 4, 5, 6. There's actually 6 in this little section here, but it's not as much as 8. So let's take a look at the substituents. Let's take a look at the pieces coming off of this now that we know that it's an octane. I have a group here that are a CH3, so that would be a methyl group. And over here, I actually have 2 carbons on here, so this would be an ethyl group. And now I have to determine which direction do I do the numbering system. I have 2 different things coming off of this. So if you have 2 different substituents coming off of it, you go from each end, and if one direction gives you a lower number than the other one, that's the way you go. So methyl, let's take a look at this. If I go from left to right, methyl would be coming off carbon number 1, 2, carbon number 3. If I went from right to left, and don't forget this bends, I have carbon 1 on this end of the chain, here's carbon 2, here's carbon 3, and notice this that it's coming off of would actually be carbon number 4. So if I went from left to right, the first thing that comes off would have the number 3. If I went from right to left, the first number would be 4. You use the lower number. So this would not work. I'm going to scratch these out because these are not the numbering systems we're going to use. So here's how it works. Once you determine the numbering system, we know going from left to right is the lowest number, then that means you must maintain that direction for the rest of the molecule. There's no switching back. So I have a 3-methyl, so I'm going to go ahead and write that down. This would be carbon 4. Remember, I have to go in the same direction. This would then be carbon 5. I know it's written a little lower than that, but I scratched that out. So this is coming off of 5. So that means I have a 5-ethyl. So I have a 3-methyl and a 5-ethyl coming off of octane. Well, on a previous example, we learned to list these. We do them alphabetically, not by the numbers, but by the letters alphabetically. This is the letter M, and this is the letter E. Which one comes alphabetically first? E. So let's take a look at the full name. 5-ethyl 3-methyl octane. It is not a 4-ethyl 6-methyl octane. That would be numbering in the wrong direction. Now I have a line structure. The longest continuous chain, regardless if it bends and twists. So let's take a look at this. 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6. That's only 6. So I know the longest continuous chain, regardless if it bends and twists, it's 7. So this is using the line structure. Tane, because it's all single bonded. And then I have a branch here coming off. It's only a single carbon because it's only a single line. So that would be a methyl group. And let's figure out where that's coming off. You can see on this line structure, you can already tell that the lowest direction would be going from right to left. So let's number the carbons. Let's not forget there is a carbon on the end. So there's carbon 1 there. There's carbon 2 here. And this is carbon 3 of a total of 7. So methyl is coming off carbon number 3. So that's a 3-methyl group. There's no other substituents. So when I name this thing, it's going to be 3-methyl heptane. On this example, I did a couple of things on this to check the format with you so you can take a look at it. First thing is did you see how I brought these over to the side? This is part of the longest chain, and this is actually a substituent. So we already know that's going to happen. So let's go ahead and get this part circled here. I'm going to bring this around so you can see it. But then I did something over here on the end, and I showed you this on a previous slide. I don't know if it was this video or the previous one, but do you remember when we had CH3 and then 2? This is telling me I have 2 CH3s coming off of this carbon. So one of the things I do if I have this situation, I'm trying to name it, is I'll actually get rid of these parentheses, and what I'll do is I'll physically draw in one of these CH3s because it's telling me I have 2 of these groups coming off of this carbon. So instead of having 2 in this parentheses, I draw one up here and I keep this one here. And then, you know, when things are printed, you can't erase it. So if you're taking a test or something that's printed, what I do is I just scratch that out, and I can see now that this carbon is bonded to this CH3 and this CH3. Do you see that? So my longest continuous chain is actually one of these, not 2 of them, but I have a branch or a substituent up here. So let's go ahead and name this. I'm going to go ahead and use my model up here. This is the same thing. I need to figure out, am I going to start from this end of the parent and go this way to do the numbering system, or am I going to start on this end and go this way? So if I go this way, do you see that this is carbon 1, 2, 3, that this methyl group here? Let's go ahead and just name it methyl. I have a methyl group here. It would be coming off of number 3 if I went in this direction. And over here, I have another group. Let's go ahead and just name it methyl while I'm here. But I have a substituent coming off this direction. And what number carbon is that coming off of? It's actually carbon 2. So a 2 beats a 3. So this is not the direction to go. This is carbon 1, 2, 3, 4, 5, 6. I'm going to go ahead and just number this one. Now you can number all these other carbons in between if you want, but did you notice I really only needed to know what carbon my substituent's on? So this is going to be a 6-methyl, and this is going to be a 2-methyl. I just noticed something. What I didn't do is write my parent name. How many carbons do I have in my parent? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. So the parent name is octane. That's going to be its last name. So now I have a methyl and another methyl. How do you handle it when you have 2 of the same things? Well, what you do is you tell in the name, you instead of writing methyl and methyl, you write dimethyl. And did you notice I have these 2 different numbers? I have the number 2 and the number 6. I have a comma between 2 and 6 and a dash between 6 and D. So this now becomes the substituent that goes in front of the octane. All right, if more than one of the same substituent is there, you use the prefix di, tri, tetra, and so on. I really haven't seen these prefixes have to go much further than 4, which is tetra, but if you had to, then you do penta and hexa and those prefixes that you already know. This is really important to keep in mind. Prefixes are never used to alphabetize. When you're putting them in order, it's only the actual alkyl name or the halogen name that puts it in order, never the prefix. And you can see why, because if you have the prefix di and you use that to alphabetize, that would put it in a totally different spot if the prefix was tri. Do you see how that moves it around? So that's why you don't include ever the prefixes in alphabetizing. And again, you must put the address of each substituent even if they're the same. Now, this isn't a 3,3-dimethyl. This is just the one we're answering, but this gives you an example. I have 2 methyls, that's what the di is telling me, and they live on carbon 3 and 3. That's just an example. Again, that's not this name here. So we already took a look at this. We saw that we had 2,6-dimethyl octane. So that would be the complete name of this one. For this page here, what I want you to do is I have all these structures. I want you to give me the IUPAC for each of the following. Go ahead and pause the video, name all of these or as many of these as you can, come back and check your work. All right, the first one has the parent name of hexane. 1, 2, 3, 4, 5, 6. This one was pretty straightforward. The formatting of this, I went ahead and put the 6 in a row here. If you look for the longest continuous chain, regardless if it bends and twists, the formatting should not be an issue. You know, when you have the knowledge, the format won't matter how they draw this. So I have 6 of these in a row, and that's the hexane. And remember, you were coming up with the name, so I'm not going to be looking up here. I'm actually going to look down here. So I know my last name is going to be hexane. Sorry, that looks like hexane. And I have a methyl group, another methyl group. So that means I would have a dimethyl. And I have this group here, so that would be an ethyl group. So these are my notes. And the numbering system, you could see that if I go from left to right, I hit the number 2. If I go from right to left, it's 3. So the numbering system, this would be a 2-methyl, a 3-ethyl, and a 4-methyl. So let's see, ethyl would get a 3 in front of it, and my dimethyl would get a 2 and a 4, so 2, 4 dash dimethyl. So again, this is pretty sloppy, but you can see up here I've got it nice and neat. So I know it's a hexane. I have a 3-ethyl. I have 2 methyl groups off of 2 and 4. Alphabetizing, remember, you never use the prefix here. You only use M and E. So M for methyl, E for ethyl. Which is first? Ethyl. So this one here is listed first because it's alphabetically first. You guys see that here? And then it's Anytime I have a number and a letter, there's always a dash. So if you have a number inside the name, you might have to put a dash to the left. 2, 4 dash dimethylhexane, written as one word. All right, let's take a look at this one. 1, 2, 3, 4, 5, 6. And I might have a longer chain, and I suspect I do. 1, 2, 3, 4, 5, 6, 7. So this is a case where I have a longest continuous chain that does bend. And I can see here I have a methyl group, another methyl group, another methyl group. So that would be trimethyl, which means I'm going to have 3 numbers in front of that. So let's take a look at the direction. Are we going to go at the end of the chain here and work our way this way up and over? Or are we going to start on this side and come back towards the left? Well, if I go up and over, the first thing, substituent coming off of it would give me the number 3. But in this direction, the first thing is the number 2. So I have a methyl coming off of 2, off of 4, and off of 5. Again, if you want to put all the numbers in there, you can, but I only need 2, 4, and 5. So when I list this, you'll put the numbers in order, 2, 4, 5, and don't forget the dash. Oh, and I did like last time, I forgot to write down the parent. Let's see, 1, 2, 3, 4, 5, 6, 7. So the parent name would be heptane. That's its last name. And so what goes in the front would be 2, 4, 5 trimethylheptane. Let's see, I have 5 going. Now this is interesting. I have 5 going in this direction. I also have, let me change the color here. You don't have to write all this right now. I'm going to try to show you here. I have another 5 if I go this direction. 1, 2, 3, 4, 5. And I actually have another set of 5, believe it or not, when I go in this direction. 1, 2, 3, 4, 5. I have 3 different ways I can do 5. Now, usually when you have more than one way that you can do the same number, in this case 5, usually you get the same answer, but you don't in this case. All right, I want to show you, I want to compare 2 with each other. We have one set of 5 that if you go across this way, you have 1, 2, 3, 4, 5, and you have a methyl group, and an ethyl group. Do you see that? So I have a dimethyl, I have 2 methyls and an ethyl. Let me take that away and I'm going to show you the one that we aren't going to use. The one we're not going to use is this one here. If this is also a chain of 5, regardless if it bends and curves. But I want you to notice I have a methyl group like we had before, but this substituent has a branch on a branch. And so they know that this happens. And when they decided to name organic compounds, they said, you know, if you have a simpler way of naming it, you have to name it the simpler way. And I'm going to go ahead and show you in this case, this would be the correct way to do it because I don't have a branch and a branch of a branch. I have 2 independent methyl groups and an ethyl group. So this is the simpler way of naming. So the rule is if you have a simple way to name it, you have to name it simple first. All right, let's take a look. 1, 2, 3, 4, 5. That means I have a pentane. I'm going to show you my notes on this. I have an ethyl group. And I have 2 methyls, so I'm going to go ahead and write dimethyl. Get that ready to go. I already know there's going to be 2. Let's figure out our numbering system. When I go from left to right, I have something coming off carbon number 2. When I go from right to left, it doesn't start till 3. And it doesn't matter if there's 2 things coming off of 3. It's just the number 2 is lower than the number 3. That's all it is. So this would be carbon number 2. This would be carbon number 3. So ethyl would be a 3, and my dimethyl would be a 2. 3-dimethyl. Alphabetically, remember this prefix here, this multiplier di is never included in alphabetizing. It's the M here and the E here that I compare. Ethyl comes before M, methyl. 3-ethyl, 2,3-dimethyl pentane. So normally when you read the name, I know in the past I was reading out the commas and the dashes. You don't include those when you read the name out loud. You would say 3-ethyl, 2,3-dimethyl pentane. All right, longest continuous chain regardless if it bends and curves. So sometimes when you have these line structures, the program will actually put the carbons on the end, and they did in this case, and sometimes they're not there. So in this case, they are there. So I have 1, 2, 3, 4, 5. I have 5 carbons, so that gives me the last name of pentane. And I have a substituent, in this case, of chloro. And I have a substituent, another halogen, bromo. Numbering system, going from left to right, notice chloro is on carbon number 1, 2, and in the other direction, bromo isn't until 3. So I have a 2-chloro and a 3, that's carbon 3, 3-bromo. Now putting these together, B and C, which one comes first? Bromo. Remember, it's not the numbers that tell me how to list it, it's alphabetizing that tell me how to list it. The numbers are a physical thing we did before that. 3-bromo, 2-chloropentane. All right, this one right here, longest continuous chain. Apparently I like pentane a lot. This is pentane. And I have a methyl group. That's a methyl. And this one's coming off carbon number 2. In fact, this is kind of a simple one compared to some of the other ones we've been doing. 2-methylpentane. One reason why I actually have it in the location that it is relative to the others is I want you to know that not always are the questions in difficulty order, like the easy ones are first and the harder ones are later. If you come across a question and you're not sure how to do it, skip it. Try another question, come back to it again. All right, this one has that abbreviation of CH2-8. What does this 8 mean? That means I have 8 groups of CH2. I just didn't want to write them all at the same time. It'd take up a lot of room. So let's take a look. Longest continuous chain is this whole thing. I have 8 carbons, 9, and 10. In fact, there's no substituents. It's just decane. And the last one on this list, I just happen to have it bending on both ends. 1, 2, 3, 4, 5, 6, 7. So that's a heptane. Let me get myself some room here. Oops, touched the wrong part on my thing. Hep. Oh, it's just not, it's too low on my, it's a little too low on my thing. I'm going to go ahead and write it over here. I keep touching my pad here. Heptane. And 1, 2, 3, 4, or 1, 2, 3, 4. Did you notice whatever direction I go, this is coming off carbon number 4? And this is the first time we've used this. This is a propyl group. Propyl. Coming off of 4. 4-propyl heptane. So this is an example of my notes and the answers. So for this slide, this time I gave you the name, and I'd like you to draw the structure. So I'll go ahead and do the first 2 for you, and then I want you to go ahead and pause the video and then see if you come up with the same structures I have. So I'm going to show you my technique on this again. So the way I like to do this is when I'm given the name and I have to draw the structure, I like to underline the pieces that I've used, and when everything's underlined, I know the last step is to fill in the right number of hydrogens. So the first thing I do is I look at the parent. This is bute and A&E. So that's telling me I have 4 carbons single bonded. 1, 2, 3, 4. 4 carbons single bonded. That part's handled right there. I have a methyl group, which is a single carbon, and this doesn't tell me how many methyl groups. This tells me where it lives, the address. So I have a single carbon coming off carbon number 2. And I know it's a methyl group, so I'm going to go ahead and put in my hydrogens at this point because I know that's what a methyl looks like. So then when I come up here, I check that I have a methyl. I check 1, 2, it's off a 2. Yep, I've got everything. All I do is fill in the hydrogens. This carbon has 1 bond to carbon, so it needs 3 hydrogens. This guy has 1, 2, 3 bonds, only needs 1 hydrogen. This needs 2, and this needs 3. So when we are given a name, the terminology we use is we'll say draw the structure. So this is called drawing the structure. All right, I'll do one more for you, and then I'm going to go ahead and have you pause the video and then do it on your own and come back and check your work. So hexane. Hex is how many carbons? 6. And A&E tells me single bonded. 1, 2, 3, 4, 5, 6. So hexane is handled. I have 2 methyl groups. Do you see the die? This is address, how many? 2 methyl groups. So where do they live? They live on 3 and 4. So one of the things I didn't mention on the previous one is I can actually call the first carbon I wrote here carbon 1, or I can call this one over here carbon 1. All right, so I have 2 methyl groups coming off of 3 and off of 4. 1, 2, 3. And sometimes when I have methyl groups that are next door to each other, I'll go ahead and write one above and one below. That way I don't get really close to them and kind of squish them together. So you can notice here I wrote this one down and this one up. I could have wrote them both up, both down, or whatever I wanted. All right, so let's check my work. Did I put 2 methyls? Yes. So there's my 2 methyls. Did they live on 3 and 4? Let's check. 1, 2, 3, yes, and 4, yes. So this next step, again, is when you fill in your hydrogens. Keep in mind, carbon must always have 4 bonds. Find out how many bonds it has before you filled in the hydrogens, and then make sure you count. You can even count afterwards. The carbon always has 4 bonds. This carbon has 1 bond already, so it needs 3 hydrogens. This one needs 2. This one needs 1. This needs 1. This needs 2, and this needs 3. All right, so at this point, I've given you 2 examples on how to do it. I want you to go ahead and pause the video, draw the structures yourself, and come back and check your work. So here's the new stuff. 3-ethyl, 3-methyl pentane. So you should have 1, 2, 3, 4, 5 carbons in a row. And my ethyl and methyl live on the same carbon. I could have put my methyl on the top or my ethyl on the top. It doesn't matter. All right, 2, 3, 4, 5. Tetrabromoheptane. Well, this one has 4 bromos coming off of a parent chain of 7, and they live on carbons 2, 3, 4, and 5. So 1, 2, 3, 4, 5, 6, 7. I have a bromo, and I could have written them all on the top like I did here. I could have them all on the bottom, or I can alternate them like I did up here, just so long as they're on carbon 2, 3, 4, and 5. And then filling in the number of hydrogens, this one should have 3. Remember, on the left-hand side, you could have the hydrogens on the left, only the left-hand carbon, or the right. And then from there on, hydrogens must all be to the right of that carbon. So this carbon needs 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen. All right, for this last one here, I have octane, 1, 2, 3, 4, 5, 6, 7, 8. All right, number of hydrogens. This guy gets 3. This guy gets 2. This only gets 1. When I wrote my ethyl, you need to make sure, be very, very careful when you do ethyls, that the carbon coming from the parent only gets 2 hydrogens, and it's only this very last carbon on an ethyl group that gets 3 hydrogens. So then let's go back to our main chain. This needs 1 hydrogen, 2 hydrogens, 1 hydrogen, 2 hydrogens, 2 hydrogens, and 3. And then again, check that your ethyl, that wherever it's attached to the parent chain, the carbon that's attached to the parent chain only gets 2 hydrogens, and the terminal carbon gets 3. All right, last one for propyl nonane. 9 in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9. Probably didn't give you enough space there to write. I noticed I had to make this smaller. Sorry about that. And I have 1, 2, 3, 4. Coming off number 4, I have a propyl group, 1, 2, 3. All right, because this is the upper division organic chemistry course, we do need to know how to do complex names. So we did have that first example where if you have a branch of a branch, if you have a simpler way to name it, you must name it the simpler way. Well, sometimes you don't have a choice. Sometimes there just happens to be a branch of a branch. So taking a closer look at this, let's go ahead and take a look. We can see that they made our longest continuous chain, the parent chain, in pink. I like how they did that. If you were to continue and count, you could see this is 6, 7, 8, 9. This is not a longer chain. This is the longest chain. So let's go ahead and do what we've done in the past. I'm going to go ahead and circle the longest continuous chain. And I have a methyl substituent here and another one here. This is not a methyl. So I'll show you how to name that in just a second. So right now I know I have 2 methyl, so that's dimethyl. And they gave us the numbering system, and you could see this too, that going in this direction would be the lowest direction. So I have a 2, 3, that's a comma, dimethyl. I'm sorry, it's written very, very sloppy. Try this again. 2, 3, dimethyl. There we go. That's a little bit neater. Get that out of your way. Now, how do you handle this? Well, we know it's coming off carbon number 6, but I have a branch of a branch. So they expanded over here and they show you what you do is you would name this as though it was its own little compound, but you still give it a YL ending because it's not a complete. So let's take a look at this. My longest continuous chain, and you would start numbering from where it's attached here. This would be carbon 1. See how they made this carbon 1? So I have 3 here, so that would be propyl. And I have a methyl coming off carbon number 2. Do you see that? That's a 2-methyl. So this little group has its own name as 2-methyl propyl. Remember, this doesn't become propane because it's not the parent. Only the parent gets the ane ending. All right, so I went ahead and cleaned that up so you can take a closer look at the structure again and how they named it. So we notice that the parent name is decane right here. So we have 2 groups coming off of here. We have a 2-methyl propyl group, and we also had, let me write that down. Remember, we also had a 2,3-dimethyl group. Well, it's the M that gets alphabetized here and the M that gets alphabetized here. So this is still listed alphabetically. This dimethyl is alphabetically before methylpropyl. And then don't forget to bring the numbers with it. Check your dashes and your commas. Your textbook has more examples of this, so you can go ahead and take a look at the textbook, or you can even take a look online for more examples. Now, I do have one more on the next slide of a complex. Okay, so before we get to the one more example, I do have one more note I want to give you. I did tell you that the prefixes di, tri, and tetra are never used in alphabetizing, but there is another note you need to know before we finish naming. For alphabetizing purposes, the prefix iso is considered part of the name. So remember we had isopropyl? So I, right here, this I piece here, would be part of alphabetizing. Now, if it's hyphenated, like sec-butyl or tert-butyl, those are not included in alphabetizing, and again, neither are the prefixes. Okay, one thing that I need to make sure that I mention before we go to the next example, I have one more example of a complex name, is this group here, 2-methylpropyl, needs to be in parentheses. And then outside of that, you tell what number it is, where it's located on the parent chain. So this special name here, this whole piece right here, gets in parentheses. And so I know coming off of 6, I have a small chain of 3 with a methyl coming off of 2. So using this information, let's take a look at my next example. Draw the following, and so what I have in parentheses is going to be what's coming off of the branch. And remember, you count away from the parent chain. So go ahead, and I want you to challenge yourself. Go ahead and see what you can do from this name and see how close you can get to the drawing. Go ahead and pause the video, come back, and check how you did. All right, before I show you the digital version, the nice clean version, let me show you how I'm going to go ahead and do this. We'll start off here, octane. That would be 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to just work my way going up. I have 2,3-dimethyl. So coming off of 2 and 3, I have 2 methyl groups. So we'll call this number 2, CH3. This is number 3, so I'm reading left to right. Once I choose a direction, I must maintain the direction for the whole molecule. And now off of number 4, that would be this guy. I have, let's go to the end here, I have an ethyl group. How many carbons is ethyl? It's 2. So coming off of 1, 2, 3, 4, I will have 2 carbons. 1, 2. I could have drawn the carbons going straight up or off to the side. I just did this for space. All right, so now I've handled the ethyl piece of this, but what I don't have is this piece here. When you work your way from the parent chain, the octane, when I go away from it, this is carbon 1. And notice my bromos aren't on carbon 1, they're on carbon 2. So my bromos, I have 2 bromos, they would be coming off of this carbon. So I'd have a bromo here and a bromo here. I want to go ahead and clean this up, so I'm going to go ahead and get rid of this and show you my digital version. So it's very similar. Here's 1, 2, 3, 4, 5, 6, 7, 8. Here's my ethyl. Here's my 2 bromos coming off of it. So for hydrogens, let's go back to the left here. This would have 3 hydrogens. This one would have 1 of our parent. This would have 1. This would have 1. 2 hydrogens, 2 hydrogens, 2 hydrogens, 3. And as we go up our ethyl group here that's inside the parentheses, this would get 2 hydrogens, and this one would get 1.